So this is sort of a status update. One of the things that we wanted to do with the Diana project was look at in general interoperability of HEP tools with other tools, sort of in a larger software ecosystem. So we had, I guess, Sebastian, you gave a talk maybe almost a year ago or more. And you've been trying to pick this up over the past year. So Manuel and Sebastian have been working on sort of push this forward. And so we have today a presentation from Manuel about the work that's happened recently on the use of Mathematica and HEP. So why don't you go ahead?
Yes. So I will start with the interaction of Mathematica and basically with root. So the short structure is the motivation. Then I will present the single steps or what is possible with these interactions, and then summarize. So why do we want it? First, so since Mathematica is widely used in theory, and you also want to compare your results with experimental side, so Mathematica would be a possibility if you can interfere with root to interact with the experimental side. And secondly, also if you're experimentalist, for example, and you want to use some analytical functions in Mathematica, like integral or something else. And this is another topic. And also, if you want to quickly check something, there is Mathematica a good tool, which I also will describe later. So it's also good for test beams or something else. And then also, can you directly analyze big data sets with Mathematica from those big experiments? So first of all, there is this Mathematica importer for root files. Mathematica is a tool in which you can take advantage of its nice and simple plotting features. For example, in root, you have to set up everything in a big code first, and then you can do nice plots. But with Mathematica, you can, in principle, directly plot something. And it's a quite simple language. So if you use C++ in root, you first have to get into it. And you can see on the right there's an import from th1 in this root file, and you can either directly display it as a table and see what's in there, or then directly plot it on the right down, and you can see it's already nice display. And furthermore, it allows the theorists to directly use the experimental data. And for more details, how to set it up and everything, you can. There's a link, and on the right top, there's again from the demo that you can use, for example, this th2f plot. But that's not all. So, for example, Natalia, she's working on CMS Open Data, and as you can see on the left, there's she did some studies with it, and there you can see how the tracks are of different particles. So it's quite nice and fast, or it's quickly done within Mathematica. And it would be a nice starting point for undergraduate students to get into this topic and to get used to it a bit, and then play a bit around with it. And what we got so far as feedback from this site were from the people who are using this root file importer with Mathematica. For example, this from Marvin Johnson, is from Dune, and that he says that Mathematica's rich set of built-in functions which eliminates the need to generate his own code, either root or Python, and also it allows him to have a real-time analysis of his data from the test beams. But what he's missing is some subfolder support from this root file importer, but that's something which could be fixed or could be updated. And then from the side of Natalia, she's told us that she would like to have an expansion of data types, that it supports more data types. And since this Mathematica imported for root files is back working now, we had to do minor changes in the make file, and Lorenzo Moneta did this, and now you can use it again, and it's working fine. And as well, like, new features can be implemented, but for this one also needs, like, here feedback from the community who wants what feature. And then on the other side, there is the possibility to call Mathematica function within root. So the interaction is via mathlink, which is directly included when you install Mathematica on your machine, or it's also on edX Plus at CERN. And it works on Linux and Mac OS. On Windows, I'm not pretty sure if it's working, because, yeah. And for example, here you see a code snippet that you can, for example, you have to first start Mathematica, and then you can call these functions. And then again, stop Mathematica. This has some licensing issues that you cannot run it infinitely long. And today, just half an hour ago, Lorenzo Moneta wrote us that he updated the root side for the new Mathematica 11.2 version. And there's another possibility which is like easier and maybe for some little programs or little needs, it's maybe better or faster. If you don't really need a big interchange, you can parse from root the Wolfram script. But the problem is you can only deal with strings, and so it's only useful for smaller applications. Here on the down, you can see, for example, that you call an integrate function, and the first one you get directly back the string, which is the analytical integration.
We're reconnecting in case people can't hear. No, I don't see anything either. No, but I
Sebastian,
okay, we're connecting again. Sorry for the delay, guys.
Yeah, the room dropped.
I'm assuming you guys on the outside haven't been hearing us. We're trying to reconnect here in the room.
Hi, Sebastian. Yeah, you dropped out. The CERN room dropped out. So
they're trying to get us back on there, but it's taking a minute. Hang on.
Can you see the slides again or not?
you can see
I think the slides are visible, but the sound wasn't coming through. Oh, did you guys mute the microphone by chance?
No, that's not the mic.
Ah, okay.
Normally,
No, the room is gone, Sebastian.
Right. No, the camera of the room is gone, but also the only reason you're hearing my voice is because I also have video running on my Mac.
Yeah. Can you pass your mic to the speaker, then we can continue.
Yeah, that's a possibility, actually.
Can you hear now? Again? From here?
I mean, one of the things that will happen is the video won't be recording this session anymore if we switch to my Mac. Shall we?
Sebastian, it's recording everything, so it's recording even now.
Oh, okay. Okay, do you want to use this? Or, I mean, you need a microphone.
Yeah.
So take that.
That's strange.
So, can you hear me now?
Yes, go ahead.
Okay. Yeah, here for this small interaction with root from Mathematica. As you can see in the small code snippets there, you can also then just transform the strings into doubles. But, yeah. And then something else from more experimental side that we did, there was a new plugin written to convert the binary files which are produced from the LaCroix oscilloscope directly within Mathematica. And so you don't have to have an intermediate step again to transform your binaries from within C++, Python, or MATLAB to Mathematica readable code. And this was done by Jesus Hernandez from Wolfram. And especially for this was useful for the cloud deploy we were doing. So the general idea of it is just to have a simple tool in the browser to perform a quick data check. And the idea came up doing a picosec test beam, which is RD51 project, and it's just to quickly check the data of the time series. The principle is that one just uploads a zip format data into a web browser, and then after the computing you get an email which tells you it's finished and a specific URL. And this was realized in collaboration with Jesus Hernandez from Wolfram. So this is the browser or the web page you get then. So in principle what you do, you drag and drop or browse the file, put it in there. It should be zip file, and then you enter your email address and submit, and then you see down there this will come up as a mail, and it tells you the job is completed, and you can pick up your results there. So you click on the link and you just get all the results out of it. So you can customize which results you want, what you can upload, and so on and so on. But it's just a nice tool if you don't have Mathematica or something else on every system set up, and you just upload it and it's completely independent. You just need internet connection. And another thing I want to stress is there's also quite nice data format within Mathematica to not always deal with indices and everything. So it's quite similar to the pandas data you have normally in Python, and there you have a quite nice displaying tools, and you can directly apply density cuts. Sorry, you can directly apply cuts and then do density histograms, 3D, and so on and so on. And it's really easy to handle, as you can see here. And then also this same data format, when you perform fits, you can also store these fits directly in this data format, and it's again like this table-like data format. And if you apply cuts then on the quality of the fits or on some parameters as you wish, it always keeps your event numbers and everything, and it's fast and simple to access. And all this data I just showed is from the hyperfast silicon, which was recorded within the picosec test beam 2017. And one last outreach, what is possible with Mathematica, it's from the LIGO collaboration, which is now at the moment quite in the press and the news, and they trained a neural network within Mathematica to detect to have a real-time detection and parameter estimation of signal. So in the real notebook, which is not publicly available in public, you have a cursor with which you can go through your data, and then it tells you if there is a signal or if there is not a signal. And it's really real time, and it's quite nice. This Wolfram guy showed us how it's working, and it's quite impressive. And as you can see, as a human being, normally with your eye you cannot detect anything in this data on the left. So, and it's a quite nice tool, and what is all possible with Mathematica. And the paper will be out soon, as they told us. And yeah, finally, a quick summary that from the motivation at the beginning. So the interaction with theorists and the experimental side can be realized via the Mathematica importer for these root files. And on the other side, you can make use of this analytical Mathematica tools within root by calling Mathematica from root, as I described. And there's this new version available from Lorenzo Manetta, and also there is to have a quick tool to check your data quality, for example, at test streams and so on, where you can use this Wolfram Cloud deploy and have directly this web interface. And also directly analysis of the big data sets from the experiments can be done either with Wolfram script, maybe on LX Plus, or cloud computing, or directly in Mathematica in the notebook one. Yeah, thank you.
Okay, thank you. Questions, comments from others?
You have the microphone, Manuel. Maybe you could mention the plan with Lorenzo, now that we have everything working, with all the new version changes and so on for root and Mathematica, is to release on the root pages and probably also on Wolfram pages updated instructions for both Mathematica with root. As you said, we have to distribute the makefile.
Yeah, so could you hear this? That we are updating now the root page and the Wolfram page for both Mathematica calls root and this the other side around.
So you're going to have support from Mathematica, from Wolfram now, or for this? You're going to have support from root team and from Wolfram as well?
Yes.
Yes.
Okay.
They're both functioning. We just have to update the web pages for both root and Wolfram. I mean, sort of redundant, but Wolfram has a web page for it, and the root pages will also link to the Mathematica root.
Okay. Yeah, I think it would be, in fact, you mentioned interaction with theorists. It would probably be interesting to have actually a phenomenologist trying to use that, because sometimes they use both Mathematica and root.
Yeah, and so it would be quite easy for them, or easier.
Yeah, to do maybe do some gymnastics that they wouldn't need anymore. That's probably useful. Yeah. Certainly useful.
Yes.
I think the number of theorists who do both is sort of small. They say, well, root we don't touch.
I actually know.
Oh, yeah?
My collaborators actually use both, and at some point I was trying to get some data from them, and I had to ask a friend, and it was doing all kinds of gymnastics because I have a way of getting a needful function in a way that I could use it myself. That you guys are doing there. So
yeah, that was part of the idea. And I can say there are examples in high-profile talks to the CMS Collaboration Week, where not Gavin Salam, but someone else in the theory group did a lot of work on phenomenology to help with people doing searches and so on, and then gave his notebook to the CMS collaboration as a useful tool. And a month later, 3 months later, I asked, did anyone in CMS ever look at the notebook, the Mathematica notebook? I mean, so this promotes that kind of interaction. So this will be good. Yeah.
But how does it work, the access to these Wolfram clouds? So everyone can access and put the codes that they want, or only?
Like
you could talk about your experience.
Yeah, if you want to put the code in it and get everything ready, then you have to have an access to the Wolfram cloud, where you have to have an account. But if you want to put some data in it and to use this tool.
So in his case, he gave us public Wolfram cloud, so anybody could just put data there without any special license. That's what we were originally working with. Jesus.
No, like if you want to put the code there to set up the cloud, you have to have an account on the Wolfram cloud account. Right. But if you want to use it, then you don't need an account.
How do you get the account? Is something easy to get? Or?
Well, we're talking with CERN licenses to see what CERN can add to be more useful to its license for users at CERN.
Yeah, for the moment we got provided accounts from Wolfram.
But you had access at Freiburg to a cloud account, or no? Or was that
Because I'm not pretty sure.
I'm not sure. But this is the kind of thing we're trying to do also with the theory group at CERN, is to just have a discussion with Wolfram and the users and the guys in charge of the license at CERN, John Evans, and see what do they have that are actually useful for people. What do we need to change in the license, if anything, to make it available? Like many people, I think, are not aware that Wolfram script comes free with the license, and it's very useful. Something, so you run something in Unix, you run the bash job in Unix. So, but anyway, does Natalia want to say anything about her experience?
Yeah, hello. So I tried to use root files in Mathematica as my project during the Wolfram school this year, and I found out that there was a problem. Like there was already did some work in this way that Mathematica can read the root files, but the format of the root file should be a very simple one. So like integer or float, double should be written only in the root file. Then Mathematica could read this and plot. It is possible to plot a two-dimensional plot, as we saw already, or three-dimensional. It's okay. But for example, in my case, when I wanted to read the real data, I was need to do the intermediate step. So because the format of the files written in the real data is quite complicated, and Mathematica cannot read it. So it should be either those scripts that connect root files to Mathematica should be rewritten, that it can read, for example, the headers from the software that different collaborations are using. Yeah, in case of CMS collaboration, it's CMSW, for example, in order not to do the intermediate step. So, and since we didn't have it at that moment, so, and I guess for now we also do not have it, I was need to do the intermediate step, so to use the CMS software. That I wrote a script in C++ that took those open data and rewrite it in either in TXT file with the variables that are interesting for the user and the parameters that is corresponded, like a momentum, eta distribution, and so on. Or those script also can provide the root file in such a format that the Mathematica can read it. And in my work, I was showing then how the root program, how the Mathematica could use those simple root to to play a bit with the data, or those, for example, result what we saw on page number 5, it was provided by using the TXT file actually. So where for each event there was written how many jets were produced, how many neurons, and so on, and corresponding values for that. And then using the Mathematica tools, we could pick up the momentum from each of the particles belonging to the event and show and reconstruct the event. But the problem here is that when we produce those readable TXT file or root file, it's still quite large to read with Mathematica. It takes quite long time. So then there is necessary to do also kind of preselection or whatever, because Mathematica cannot read a very huge amount of data. And also it is not possible to store a lot of data. We have like terabytes data available, and it's too much for the Mathematica. So it should be somehow some intermediate steps that also select or open in Mathematica those events that are interesting with the users. So you need to do the preselection events already in the 0 step, so to say.
Natalia, I hope you got your message to Wolfram, because they're very keenly aware that they need to find a way to go to larger data sets to eventually do computing out of core, and so on. And they're just not. They need more pressure.
Yeah, the problem is they store everything in the RAM, in the memory.
Yeah.
And that's
quickly limited.
That limits you to gigabytes.
Yes, and then
even if you only look at 2 variables, it's
but it's not only for our data. I mean, Wolfram people realize that's their next step they have to take. Yes.
I have one question that I didn't quite understand in Natalia here. It's when you say for experiment formats, but I think that's a general. It's not even a problem. It's just how it is. You can't expect software to read every experiment's raw root files because they contain complex experiment-specific objects.
Yes, exactly.
We're finishing the meeting in the next 10 or 15 minutes.
Right. So this is not, it has nothing to do with this problem here. I think, for example, if I give you my raw files from HEP, you will never be able to read them properly unless you have the software behind it to define the proper, well, all the reflection information. So I think this is, when you said that you had to massage the data, I assume that what we're talking here about is root files that have essentially histograms and trees.
yes, and
That's
like
because all the rest is indeed other formats that are raw, kind of want to call it.
Yeah, but sorry, those raw data, it also consists the trees, branches, and leaves. But the format of the leaves is quite complicated, and only with those CMS software, for example, it is possible properly to read those information. And maybe then it's like it's not so many. I don't know. Like those large experiments, it is possible, like to find people that will kind of adapt the software from the experiment to Mathematica. Then Mathematica can kind of using those work what is already done, those headers and whatever, to read directly the information from root files, those raw root files.
Okay.
Thanks. Yeah. Okay. Good. So,
other questions or comments?
I guess I had one about this data format that's called similar to HDF5. Can you say more about what that is and how easy it is to get data in and out of that format?
Sure. So this one, like for example, there we just read in here text file, but you can like read everything in what is Mathematica supporting, and then you say it's table format, and you directly have this format. And where is it here? This this command data set already pushes them or converts them in your data format, and then you can easily access it. Like what is done here, even here there's are some cuts performed. And
Right. So I can ask a question a different way. Is it something that you can imagine having tools that go from that data format to Python, or from create the data format, a data file in Python or in root, and then save it without being something like text for use in Mathematica?
Yeah, for example, if you store it in HDF5, that's like almost like most of the time you store them with PyTables, and for example in HDF5, and I think that's you can directly read it then out with Mathematica.
Okay, so this thing you're calling a data format's really an internal Mathematica feature, but in any case you could just use HDF5, which is good. So, okay, yeah. Now I understand things.
I mean, isn't that unique that the data set structure creates associations, which are...
Yes, like it's
a powerful tool in itself.
Yeah, the comparison is that, yeah, you can, it's within Mathematica this dataset tool, but you can read an HDF5 and whatever format, but it's handling it like when you use, for example, HDF5 with in combination with pandas, then you call everything with strings, or you can have a better cut. You can cut wire strings or something like this. So it's and it's like a bit also like NumPy. It just cuts these things out and is quite faster.
You were calling Mathematica from root. What was it on C++ prompt? Can you do the same from the Python prompt or not? Or if you have everything installed, like for example on Alex Plus. Or is this is just C++?
I think
right?
when it's like you have to do it while first with a makefile with C++, you have to compile it, and at this point, then I'm not pretty sure if you really can do it with Python.
The technicality.
Yeah, but like.
You did mention the makefile, but then in the script it was not there, so that's why I didn't.
Yeah, like that's quite a larger procedure to set it up and to link everything correctly.
Yeah, okay.
And then if you want to do easier things, you can just you just push it to the bash, and you get back your either whatever you want. You just have with Python it could be even simpler, because here in C++ you have to cast all the T strings and all these data types that it's working properly.
So, thanks.